We're going to take a look at how we can utilize MATLAB to be able to perform some elementary vector operations. So we're going to define some vectors, and then we're going to perform some of the operations and computations that we've looked at throughout our course with respect to vectors. And so what we're going to do first is we're going to note that there's three kind of main computations or sort of commands that we would use. So we have this dot UV. So if we have a vector U and a vector V, it finds the dot product. We have cross UV, and that's going to find the cross product among U and V in that order, U cross V. And then finally, the norm of U is going to find the magnitude of U. All right, so let's say, for an example, we have a vector U as 433 and a vector V as -340. And we want to write some MATLAB code to compute 2U plus 3V to find the dot, the cross, the magnitude. So that's going to be these three. And then we're going to do a little bit more, I guess, a little bit more intrinsic operations where we go through and find the angle between the two vectors. And we're going to need a formula for that. And then finally, we're going to find the vector of magnitude 4 in the opposite direction of V. All right, so let's just start with these first four, and then we can move on. All right, so first thing we do, we have our CLC, clear all. And we're going to start by defining our vector U. And to define a vector in MATLAB, you're just going to say U and then bracket. And we're going to have our vector, which was 4, 3, 3. I'm just going to put that inside. And it's going to be 4, 3, 3, close parenthesis. And if I run it, here we go. We have 4, 3, 3. Now we have a vector V that's going to be equal to -3, 4, 0. Right? And then we're going to go ahead and run that. And I could go ahead and unsuppress both of these by getting rid of the parentheses. So here's our vectors U and V, and then we put our semicolons to suppress. All right, so we need 2U plus 3V. And this is actually really easy to do because all we're going to do is just say 2 times U plus 3 times V. And we're just going to run it. And there it is. There's the vector 2 times U plus 3 times V. Nice and easy. If we want the dot product, we're going to say dot U comma V. All right. And of course, we could do this by hand, and we end up with a dot product of 0. If we want to, we can assign them to vectors. OK, or we could assign them, to variables. But let's just go ahead and do the output. We want the cross product, cross of U comma V. All right. And we're going to execute that. And this is our cross product. All right. And then we need the magnitude of U. All right, and again, what I'm doing is I'm just going here. Here's our U cross V, or U dot V, U cross V, magnitude U. So now we need norm of U. All right, and it's going to give us a decimal value most likely. So that's about the length of in standard position of our vector U. All right. Now, the other two questions, we have to go through and think about that a little bit because it's not just an operation in MATLAB. So we're going to have to kind of finagle this. So we want to find the angle between U and V and then print the result in degrees. Now, you probably remember that to be able to find the angle between two vectors, we use this formula. We have the cos of theta equals U dot V divided by magnitude U times magnitude V. All right. So that was in one of our sections in the lesson. And then also, while we're at it, let's just go ahead and figure out what we're going to do with that. And so that means that theta is going to be equal to the arc cos by taking the arc cos of both sides of U dot V divided by magnitude U, magnitude V. Now, what's going to happen is in MATLAB, this is going to give us the answer in radians. So what we're going to have to do is we're going to have to multiply that by 180 divided by pi. All right. And that's going to help us to get into the degree conversion. All right. So we could just do that really nicely. So let's go ahead and work on that one. Then we can come back and do the one with the magnitude 4. All right. So I'm going to say that we're going to have the A cos, which is the arc cos. And then in parentheses, I'm going to have dot UV. Okay, and again, I'm just using this formula that we just constructed. So arc cos U dot V, and then I have to divide that by norm of U times norm of V. All right, And notice it still has a red underline. Remember, you can always hover over there. And it says it might be missing a closing parenthesis. So let's give it a closing parenthesis. There we go. And it looks like it still might be missing one. So I'm going to insert another parenthesis. All right, so that's what I would recommend is if you ever get these syntax errors or red underlines, maybe just hover over it. Like this one just says that we need a semicolon. All right, no big deal. So, but we don't want that because then we wouldn't see the answer. All right, now I'm going to execute this and it gives me 1.5708. And that doesn't really help us because that's in radians. So what I'm going to do is I'm going to multiply that by 180 over pi. And that's going to give me the measure in degrees. And if I go ahead and run it this time, I get 90 degrees, which should be absolutely no surprise to anyone because remember what the dot product was. Remember we found dot UV and that was 0. And you probably recall that if the dot product between any two vectors is 0, that means that those vectors are indeed orthogonal to one another. All right, so they form a right angle. This error just says suppress it with a semicolon, which we don't care about because if we did that, we wouldn't get the output. All right, one last problem, and that is going to be able to take our, not sure what happened here, no big deal, I'll just erase it. We're going to find a vector of magnitude 4 in the opposite direction of v. And that means that we have to go back and kind of remember how to find the vector of magnitude 4 in the opposite direction. All right, so while I'm getting rid of this stuff, it's not making it easy for me. Regardless, we could just go through and draw it down here, or maybe there it is. Okay, it's just, I think it's offline and it's not liking me too much for some reason. All right, so, well, regardless, oh, there it goes. All right, so to be able to do that, you probably remember that to be able to find a unit vector, you have to use the formula. So we have our unit vector. So this is all over the place. All right, so the unit vector in the same direction is going to be the magnitude, or I'm sorry, vector v over the magnitude of v. All right, and remember this has a length of 1. All right, because that's what a unit vector is. All right, now if we multiply that by -4, so now this has a magnitude of 4, because remember it had a length of 1 initially. Now it has a magnitude of 4 in the opposite direction because of that negative. All right, so all we're going to do is we're going to use this formula. So we're going to take -4 times v divided by magnitude of v. We're just going to program that in MATLAB. All right, so we're going to take -4 times vector v divided by norm of v. All right, so we have to be careful. Remember, we have to use the right syntax. All right, so we can't type magnitude or anything like that. And if we execute it, it gives us this. Okay, so we have -2.4, -3.2, and 0. And that makes sense because if we were to go through and find the magnitude of this, so let me assign this to a variable c. And let's say we found the norm of c. That should have a magnitude of 4, which it does. All right, so we know that it has a magnitude of 4, and it's in the opposite direction because we have positive, -0, and this one is -0. So it's in the opposite direction. So if we wanted to format this, so let's say we had one of the answers, -4 times v over norm v. We could certainly go through and assign this to like an fprintf statement. So for instance, the norm, I could assign that to a variable a, and then I could do an fprintf, and I could say the magnitude of vector u is colon, and I'll use a %f and \n. And then I'll use the apostrophe and say comma a, because I assigned it to a. All right, and if we wanted to, not that we have to, but that we get our magnitude that way. And it works nicely. It gives us a nice formatted statement. Okay. Personally, most of us are just going to use MATLAB to be able to get the answer. We don't necessarily need to format it, but I did want to illustrate how to format it just in case you A, either want to format it, or for B, in later coursework, you do have to format it. Okay, so there we go. Those are our vector operations. And the last thing we're going to take a look at in this section is being able to work with vector value functions using MATLAB.